Wildhorse Energy is looking to transform the face of Central European energy production with the groundbreaking technology of underground coal gasification, or UCG, a cleaner and more environmentally friendly way of tapping known coal resources by turning coal fields into gas fields to create syngas, a highly valuable fuel gas used in electricity generation and numerous chemical processes. Hungary, as well as its Central European neighbours, is hugely reliant on gas imports from Russia to generate power. Wildhorse Energy, through UCG, is aiming to transform this energy dependency and provide improved energy security to the region. The initial focus is on Hungary, where several projects are considered to have geology and infrastructure suited to UCG. The Medchek Hills have established infrastructure and more than 100 years of coal mining history, and multiple known coal deposits at depths suitable for UCG. Several sites within the exploration target of 1 billion tonnes of coal have been identified as highly prospective, being close to a power station, established infrastructure, and the existing and planned expansion of the international gas pipeline network. Recent advances in directional drilling technology have made it possible to economically access large areas of previously unminable coal, otherwise known as stranded coal. A standard industrial drill rig is used to vertically drill the first 500 metres through the topsoil and rock in order to intersect the coal seam, at which point the direction is then guided to follow the coal seam to create an in-seam channel that may be up to 1,000 metres long. The targeted coal field of Pech consists of bituminous coal with energy values of approximately 22 megajoules per kilogram and is generally dipping from outcrop down to 1,600 metres. It consists of many coal layers, of which several may be considered suitable for UCG. As previously shown, directional drilling is used to construct an injection well into the coal seam. A vertical ignition well is drilled to enable the production and ignition well to intersect in the coal seam. The production well is drilled parallel to the injection well to also meet up with the ignition well in the seam. A second injection well is drilled to produce a cavity width of approximately 80 to 160 metres. This design creates a mining panel of approximately 1.5 million tonnes of coal. With the underground development completed, the system is now ready for oxygen injection. Fuel, oxygen and heat are required to make a fire. The coal acts as the fuel, whilst the steam provides the heat for the reaction. The underground coal gasification process is controlled by injecting the oxygen mixed with steam into the coal via the injection wells, where it's ignited using the ignition well. The injected oxygen reacts with the carbon in the coal to form carbon monoxide and carbon dioxide and gives off more heat. The injected steam reacts with the carbon in the coal to form carbon monoxide and hydrogen, while some of the hydrogen reacts with more carbon to create methane. This process is slowly retracted through the seam, and the product from the partial oxidization of the coal is known as syngas, which is a highly valuable gas that can be used as a fuel gas. The mining process between the injection and production well can occur at a rate of around half a metre per day. And this mining panel design may produce years of continuous production from the designed active area. Although the UCG design stretches over hundreds of metres underground, the footprint on the surface is relatively small. To extend future capacity, several modular systems can be installed next to each other, each supplying around 200 megawatts of thermal energy, enough energy to provide for 100,000 households. Panels may also be extended vertically by accessing other suitable coal seam. All the syngas from the production wells is collected and piped to the gas cleanup facility located a short distance from the producing wells. At the production facility, the raw syngas is cooled and other impurities are removed, like sulphur, dust and liquid. The clean syngas is then ready for use as a fuel gas in gas turbines for local electricity and steam generation. Wildhorse Energy's initial project and its relationship with European energy companies provide a fantastic platform for growth, monetising known coal fields near power stations and converting them to more environmentally friendly and lucrative gas fields. Through the application of UCG technology, Wildhorse intends to provide domestic energy generation alternatives to Central European countries, lessening their reliance on imported gas by using its world-class team of UCG specialists and leading energy affiliates to potentially transform the energy dynamic of Central Europe.